This is section 13.6, and this is our introduction to surface integrals. And if you remember, so far we've done 5 sections in chapter 13, and the second section, 13.2, was pretty lengthy. There's just a lot of stuff with line integrals, and then we have, simple line integrals, and then we have line integrals over vector fields. And 13.6 is kind of similar in the sense that 13.6 is a really lengthy section, and it starts with, sort of these simple surface integrals, and simple is subjective. They often are quite lengthy in their process, but it's just a pretty straightforward surface integral. And then we get into more complex ones where we look at a vector field. And so this will take us a little bit of time, but we'll get through each of the examples. I want you to read through the notes just so you have a nice sense of what's going on. But surface integrals have a sort of a direct relationship with surface area. You'll see that the surface area formula is actually embedded in the surface integral. And so the connection between when we had line integrals and arc length, and the fact that those are really similar, is really kind of a comparison to surface integrals and the surface area double integral that we did back in 12.6. So real quickly, let's just go through some reviews. So first of all, parametric surfaces, we're back in section 10.5, and parametric surfaces are where you have a vector equation for a surface made up of two different variables. We used u and v. Sometimes we use r and theta, just a variety of variables. And so just remember back to 12 or to section 10.5, and we're going to utilize this equation for a surface in vector form. And what it does is it produces a full surface as you trace out vectors along that surface and plot points, and what you get is a surface in space. And then also review is our surface area from 12.6, which wasn't too long ago. And the equation is here. It's the double integral of the magnitude of the cross product between these partial vectors. And if you remember, the surface area double integral can be sort of lengthy just because the cross product between vectors can be a lengthy process. And so given that this is part of what we're going to deal with here, you're going to find that these problems can take a little bit of time. The other thing I want to alert you to is that if we have a function f of x, y, z that's equal to 1, then our surface integral is going to look identical to our double integral surface area formula. Okay, and we'll look at that in the next little part here on the next page. But just keep in mind that there is a direct connection here, and it's important to understand that these formulas and these equations, they kind of piggyback on each other, and they're really interconnected. So anyway, this is from section 12.6, and we are now going to basically build on it in section 13.6. So the next video, what we'll do is we'll get through the definition of a surface integral, and then we will start to use that to calculate surface integrals.